Terraforming is the process of altering a planet's environment to make it more Earth-like and habitable for human life. The concept, purely once science fiction, has gained increasing attention as advancements in technology and a growing understanding of planetary science have made such ambitious projects seem more feasible. Terraforming involves modifying a planet's atmosphere, temperature, surface topography, and ecology to replicate conditions similar to those on Earth, ultimately allowing humans and other Earth-based life forms to survive and thrive in an otherwise hostile environment. The idea of terraforming serves not just as a scientific endeavor, but also as a profound exploration of human potential and destiny. It raises fundamental questions about our responsibility as a species, our ability to manage ecosystems, and our place in the universe. Terraforming is an endeavor that could define humanity's future, extending our reach beyond Earth, moving from this to this, and ensuring our survival in the event of planetary-scale catastrophes. It also offers an unprecedented opportunity to build a new world from the ground up, learning from the mistakes of Earth to create a more sustainable and equitable society. Howdy, I'm just some random nude dude sitting in my closet talking to myself. It's also where I celebrate the power of free thinking and encourage bold ideas. As a society, we're often afraid to challenge the norms and think outside the box. But here, I embrace the unconventional. So sit back, relax, and join me on this journey of exploration, where we embrace our inner nude dude and push boundaries to discover new perspectives. Welcome to the first episode of my in-depth series on Terraforming Venus, where we explore one of the most ambitious and potentially transformative endeavors humanity has ever considered. Terraforming, literally earth-shaping, refers to the process of altering a planet's environment to make it more Earth-like, capable of supporting human life and sustaining ecosystems. It's a concept that has captivated scientists, futurists, and science fiction writers for decades. And in this series, we're diving deep into the science, technology, and philosophy behind making this dream a reality. In this opening episode, I'm setting the stage for examining what terraforming actually means, why it's a subject of such intense interest, and how it fits into a broader context of human progress and survival. Terraforming is not just about engineering. It's about redefining our relationship with the cosmos and confronting the enormous ethical and practical questions that arise when we consider reshaping an entire planet. The idea of terraforming has its roots in science fiction, with early 20th century writers like H.G. Wells and Olaf Stapledon imagining the transformation of planets to support human life. These speculative visions have since evolved into serious scientific discussions, with researchers and engineers exploring the feasibility of altering planetary environments. As our understanding of planetary science and technology advances, what once seemed like fantasy is now being considered within the realm of possibility. This episode will take you on a journey through the history of terraforming, from its speculative origins to its current status as a topic of scientific inquiry. We'll explore how the concept has evolved and how it has captured the imagination of generations, influencing not just science fiction, but also real-world space exploration strategies. Terraforming is more than just a grand experiment. It's a potential solution to some of the most pressing challenges facing humanity. As we confront the realities of climate change, resource depletion, and overpopulation, the idea of expanding humanity's reach beyond Earth becomes increasingly attractive. Terraforming offers a way to ensure the long-term survival of our species by creating new habitats in the solar system, providing a safety net in case of global catastrophes, and offering new opportunities for growth and discovery. We'll discuss why terraforming is significant from both a scientific and philosophical standpoint, We'll consider the potential benefits of creating a second Earth-like planet, including the possibilities for scientific research, economic expansion, and the continuation of human civilization. We'll also delve into the ethical implications of altering another world, asking tough questions about our responsibilities and the potential consequences of such actions. Venus, with its similar size, gravity, and proximity to Earth, presents a unique opportunity for terraforming. However, its current environment, characterized by extreme heat, crushing atmospheric pressure, and clouds of sulfuric acid, poses formidable challenges. Despite these obstacles, Venus remains one of the most intriguing candidates for terraforming due to its potential to become a livable world with the right technological interventions. We'll introduce the concept of terraforming Venus specifically, outlining why it's an attractive option compared to other planets like Mars. We'll provide a glimpse into the future, imagining what a terraformed Venus could look like. A world with blue skies, oceans, and thriving ecosystems. This vision will set the stage for the detailed exploration that will follow in subsequent episodes. This first video is crucial in laying the foundation for the entire series. By the end of this episode, you'll have a solid understanding of what terraforming is, why it matters, and why Venus is a compelling candidate for this transformative process. I'll provide you with the background knowledge you need to appreciate the complex discussions that will follow as we dive deeper into the science, technology, and ethics of terraforming. As we embark on this journey together, I encourage you to keep an open mind and engage with the material critically. Terraforming Venus is a bold vision that challenges our assumptions about what's possible, pushing the boundaries of human ingenuity and imagination. Whether you're a scientist, a space enthusiast, or simply curious about the future, this series will offer you a comprehensive guide to one of the most exciting frontiers of human exploration. Welcome to the first step on the path to a new world. Terraforming, at its core, is the process of transforming a hostile, uninhabitable environment into one that can support Earth-like life. The concept, first popularized in science fiction, is now being seriously considered by scientists, engineers, and futurists as a potential solution for humanity's long-term survival and expansion beyond Earth. The word itself is derived from the Latin terra, earth, and forming, meaning the process of shaping or creating. In essence, terraforming is about creating Earth-like conditions on other planets or moons, allowing for the possibility of human settlement and the proliferation of Earth's ecosystem beyond our home planet. The scientific foundation of terraforming is rooted in our understanding of planetary systems, atmospheric science, ecology, and geology. Terraforming a planet involves a complex interplay of these disciplines, requiring an in-depth understanding of how planetary climates function, how atmospheres are formed and maintained, and how ecosystems can be developed and sustained. The first step in terraforming involves altering the atmosphere of the target planet. For a planet like Venus, with its thick, toxic atmosphere dominated by carbon dioxide, the initial goal would be to reduce levels of CO2, which is responsible for extreme greenhouse effect that makes the surface unbearably hot. This could be achieved through various methods, such as introducing photosynthetic organisms that convert CO2 into oxygen, or using chemical processes to sequester carbon in solid form. In addition to atmospheric modification, terraforming requires the establishment of a stable, life-sustaining climate. This might involve regulating the planet's temperature through the use of solar shades or mirrors in space to reflect sunlight, thus cooling the planet, or by manipulating the planet's albedo, its reflectivity, to ensure that more heat is radiated back into space. Another critical aspect of terraforming is the introduction and management of water, which is essential for life as we know it. This could involve importing water from other celestial bodies, such as comets or icy moons, or generating water through chemical reactions that combine hydrogen and oxygen. The creation of bodies of water, such as oceans, rivers, and lakes, would be a pivotal step in making the planet habitable, as these would help moderate the climate, support life, and provide a source of drinking water and irrigation. The final stages of terraforming would involve the introduction of life forms, starting with microbial life to create the foundation of a stable biosphere, followed by plants to produce oxygen and stabilize the soil, and eventually animals and humans. This would require careful planning and genetic modifications to ensure that these organisms could survive in the initially harsh conditions of the terraforming planet. The significance of terraforming extends beyond the technical challenges. It represents a profound vision for the future of humanity. As our population continues to grow and the impacts of climate change and resource depletion become more acute, the idea of extending humanity's presence to other planets offers a potential solution to these global challenges. Terraforming could provide new homes for billions of people, alleviate the pressure on Earth's resources, and serve as a safety net against existential threats such as asteroid impacts, nuclear war, or environmental collapse. Moreover, terraforming is an expression of humanity's inherent drive to explore, innovate, and push the boundaries of what's possible. It's a natural extension of our history of exploration, from the first humans who migrated out of Africa to explore new lands, to the space race that put astronauts on the moon. Terraforming represents the next frontier, a challenge that, if successful, would solidify humanity's place as an interplanetary species. However, the implications of terraforming are not just practical, but also philosophical. It forces us to confront the fundamental questions about our role in the universe and our responsibility as stewards of life. Should we, as a species, have the right to alter entire planets, potentially at the expense of any existing ecosystems or life forms that may be there? What ethical considerations should guide our efforts, and how can we ensure that the mistakes we've made on Earth are not repeated on other worlds? The ethical considerations of terraforming are as complex as the technical challenges. Some argue that we have a moral obligation to preserve Earth-like environments, wherever we find them, whether they exist naturally or are created through human intervention. This perspective is grounded in the belief that life, in whatever form it takes, is valuable and worthy of protection. From this viewpoint, terraforming can be seen as an act of hubris, a dangerous extension of humanity's tendency to dominate and exploit nature. On the other hand, proponents of terraforming argue that it's a necessary step in humanity's evolution. As Earth faces increasing environmental challenges, the ability to terraform offers a potential solution to these crises, providing new habitats and resources that could ensure the survival of our species. Furthermore, if we find no life on planets like Mars or Venus, some argue that we have a responsibility to bring life to these barren worlds, creating new ecosystems where none previously existed. The ethical debate also touches on issues of governance and equity. Who gets to decide how a planet is terraformed, and who gets to live there? How can we ensure that the benefits of terraforming are shared equitably, and that the process does not lead to new forms of colonialism and exploitation? These are questions that humanity will need to grapple with as we move closer to making terraforming a reality. Beyond its practical and ethical implications, terraforming represents one of the greatest tests of human ingenuity. The challenges are enormous, requiring advancements in technology, science, and international cooperation on an unprecedented scale. Terraforming a planet would likely take centuries, if not millennia, requiring a long-term commitment and vision that spans generations. It would require us to rethink our approach to environmental management, not just on Earth, but on a planetary scale. This test of ingenuity also extends to our social and political systems. Terraforming would necessitate new forms of governance, capable of managing resources and people across vast distances and in radically different environments. It would challenge us to develop new economic systems that can support such a massive undertaking, and new social structures that can adapt to life on another world. Ultimately, terraforming is about more than just creating a new home for humanity. It's about testing the limits of what we can achieve, both as individuals and as a species. It's about imagining new possibilities and striving to turn those possibilities into reality. In this sense, terraforming is not just a scientific or engineering challenge. It's a human challenge, one that speaks to the deepest aspirations and our most profound fears. As we consider the broader implications of terraforming, it's important to recognize that this endeavor is not just about Venus, Mars, or any other specific planet. It's about the future of humanity and our place in the universe. If we succeed in terraforming even one planet, it would mark a turning point in human history, a transition from being a single planet species to becoming a truly interplanetary civilization. This shift would have profound implications on how we see ourselves and our place in the cosmos. It would challenge us to rethink our understanding of life, intelligence, and civilization. It could lead to new forms of art, culture, and philosophy as we grapple with the realities of living on a planet that we have created. Furthermore, the lessons we learn from terraforming could be applied beyond our solar system. If humanity ever reaches the stars, the ability to terraform other worlds could be key to our long-term survival and expansion across the galaxy. In this way, terraforming is not just about creating a new home for humanity. It's about ensuring that humanity has a future, no matter what challenges we face. Terraforming is a concept that carries immense significance for humanity. It represents the ultimate test of our technological and scientific capabilities, our ethical and philosophical understanding, and our social and political systems. It challenges us to think big, to imagine a future where we are not confined to Earth, but instead are able to thrive on multiple worlds. As we embark on this journey of exploration and discovery, terraforming offers a promise of a new beginning, a chance to create a better future for ourselves and for the universe. When discussing the potential for human colonization and terraforming, Mars often takes center stage in popular discourse. However, Venus, Earth's sister planet, offers some compelling advantages that make it a serious contender for such an ambitious project. Understanding why Venus might be a better choice than Mars, or at least why it deserves equal consideration, requires a deep dive into the physical characteristics, proximity to Earth, and the potential benefits and challenges it presents for terraforming or colonization. One of the most significant reasons for considering Venus as a candidate for terraforming is its physical similarity to Earth. Venus and Earth are often referred to as twin planets because of their similar size, mass, and gravity. Venus has a diameter of about 12,104 kilometers, roughly 95% that of Earth, and its mass is about 82% of Earth's. This similarity in size and mass means that Venus has a surface gravity very close to that of Earth, approximately 90.7% of Earth's gravity. This is a crucial factor for long-term human habitation, as gravity plays a significant role in maintaining human health, particularly in terms of muscle and bone density. In contrast, Mars has only about 38% of Earth's gravity, which poses significant challenges for human physiology over extended periods. Health impacts of living in low gravity are not fully understood, but they could include muscle atrophy, bone density loss, and other serious medical issues. The fact that Venus has a gravity similar to Earth's makes it a more favorable environment for human settlement from a biological standpoint. Additionally, Venus's thick atmosphere provides another point of similarity to Earth albeit in a less immediately positive way. While the atmosphere is currently composed mostly of carbon dioxide and is inhospitable, its density and composition offer potential resources that could be harnessed in the terraforming process. Mars, by contrast, has a very thin atmosphere, only about 1% the density of Earth's, which would make it difficult to retain heat and maintain an Earth-like environment. The dense atmosphere of Venus, if terraformed, could be more easily adapted to support human life, offering better insulation against cosmic radiation and temperature extremes. While Venus has many physical similarities to Earth, its current environment is extremely hostile to life as we know it. The surface temperature of Venus is around 467 degrees Celsius, 872 degrees Fahrenheit for people in America, making it the hottest planet in the solar system. This intense heat is due to runaway greenhouse effects, where the thick CO2 atmosphere traps solar energy, creating a self-sustaining cycle of heating. The atmospheric pressure at the surface is about 92 times that of Earth, equivalent to the pressure found nearly a kilometer underwater on Earth. These conditions make the surface of Venus uninhabitable for any known form of life. In addition to the extreme heat and pressure, Venus's atmosphere contains clouds of sulfuric acid, H2SO4, which rain down on the surface, creating a corrosive environment. These clouds, along with the dense CO2 atmosphere, would need to be drastically altered in the terraforming process to make Venus more suitable for human habitation. You know, H2SO4, like in Johnny went to get a drink but fell dead upon the floor, for what he thought was H2O was H2SO4. However, these challenges are not insurmountable. The very factors that make Venus hostile also present opportunities. The thick atmosphere, while currently toxic, could be manipulated to reduce CO2 levels and lower the planet's temperature. Techniques such as introducing photosynthetic bacteria or other engineered organisms to convert CO2 into oxygen, or using chemical processes to sequester carbon, could gradually transform the atmosphere into something more breathable. The sulfuric acid in the atmosphere could potentially be neutralized or removed, either by chemical reactions or by breaking it down into less harmful components. Venus is the closest planet to Earth in terms of both distance and orbital dynamics, which offers significant advantages for exploration, colonization, and terraforming. On average, Venus is about 41 million kilometers from Earth, compared to Mars, which is about 78 million kilometers away at its closest approach. This closer proximity means that travel times to Venus are shorter, typically about 3 to 4 months with current technology, compared to 6 to 9 months for Mars. Shorter travel times reduce risks associated with space travel, such as exposure to cosmic radiation, and make resupply missions from Earth more feasible. The proximity of Venus also has implications for communication. The time delay for signals traveling between Earth and Venus is much shorter than between Earth and Mars, typically ranging from 2 to 15 minutes, depending on the planet's relative positions in their orbits. This shorter communication delay would be advantageous during early stages of colonization and terraforming, where real-time or near real-time communication with Earth could be crucial for coordinating activities, troubleshooting problems, and providing support. Moreover, Venus's location within the inner solar system makes it a more accessible destination for potential solar energy harvesting. The planet receives about 1.9 times the amount of solar energy that Earth does, making solar power a viable and abundant energy source for any future colonies. This abundant solar energy could be harnessed not only to power habitats and infrastructure, but also to drive the processes needed for terraforming, such as atmospheric modification and resource extraction. Given the extreme conditions on Venus's surface, initial human habitation would likely occur in the planet's upper atmosphere, where conditions are much more Earth-like. About 50 kilometers above the surface, the temperature ranges between 20 degrees and 30 degrees Celsius, 68 to 86 Fahrenheit, and the atmospheric pressure is similar to that at sea level on Earth. At this altitude, humans could potentially live in large floating habitats or cloud cities suspended in the atmosphere by large balloons filled with breathable air, which is also a lifting gas in Venus's CO2-rich atmosphere. And you'd want to name the first city Calrissian, wouldn't you? These floating cities could serve as the first phase of human colonization on Venus, providing a safe and stable environment while the surface is being transformed. They could be designed to be self-sustaining, with closed-loop life support systems, renewable energy sources, and the ability to produce food and recycle water. These cloud cities would also provide a platform for scientific research, allowing us to study Venus's atmosphere and surface in detail, test terraforming techniques, and gradually prepare the planet for future settlement. The concept of cloud cities is not as far-fetched as it might seem. NASA has already explored the idea through its high-altitude Venus operational concept, or, I hope it's pronounced, HAVOC project, which envisions crewed missions to Venus's upper atmosphere using airships and floating habitats. These habitats would be shielded from the harsh conditions at the lower atmosphere and could potentially serve as the starting point for long-term human presence on Venus. The ultimate goal of terraforming Venus would be to create an Earth-like environment on the planet's surface where humans could live, work, and thrive. This would involve a multi-phase approach that begins with stabilization of the atmosphere and reducing surface temperature. Over time, the introduction of water, either by importing it or producing it on Venus, would be critical for supporting life and creating a sustainable ecosystem. As the atmosphere becomes more breathable and the temperature drops to habitable levels, plant life could be introduced to further modify the environment, producing oxygen and stabilizing the soil. Eventually, animals and, finally, humans could be brought to the surface, establishing a new civilization on Venus. This long-term vision of transforming Venus into a second Earth is an ambitious and complex endeavor, but one that could offer immense rewards. Venus has the potential to support a large population, with vast areas of land that could be made fertile and habitable. It could serve as a new frontier for human exploration, science, and culture, providing a fresh start where we can apply the lessons learned from Earth to build a more sustainable and equitable society. Beyond its potential as a new home for humanity, terraforming Venus also has strategic significance for the future of space exploration and human expansion into the solar system. Venus's location within the inner solar system makes it a valuable stepping stone for missions to other planets and celestial bodies, such as the asteroid belt, the moons of Jupiter and Saturn, and beyond. A colonized Venus could serve as a hub for interplanetary travel, offering a base for launching missions deeper into the solar system. Additionally, the process of terraforming Venus would advance our understanding of planetary science, atmospheric chemistry, and ecological engineering. The technologies and techniques developed for terraforming could be applied to other planets, moons, or even used to address environmental challenges on Earth. By learning how to transform Venus, we could gain insights into managing Earth's own climate and resources more effectively, potentially developing solutions to global issues like climate change, resource depletion, and habitat loss. While the scientific and strategic reasons for terraforming Venus are compelling, it's essential to consider the ethical implications of such a project. Venus, like any other celestial body, is a unique and valuable part of the universe's natural history. Some argue that we have a moral obligation to preserve planets in their natural state, rather than altering them to suit human needs. Terraforming Venus would involve making irreversible changes to its environment, potentially destroying any undiscovered forms of life or geological features that hold scientific importance. On the other hand, proponents of terraforming argue that humanity has a responsibility to use its technological capabilities to ensure its survival and to spread life throughout the universe. If Venus is lifeless and barren, transforming it into a living world could be seen as a positive act, creating a new home for life where none existed before. Balancing these ethical considerations will be a critical aspect of any decision to terraform Venus. It will require careful deliberation, international cooperation, and a commitment to ensuring that the benefits of terraforming are shared equitably, both among people of Earth and the future inhabitants of Venus. Venus offers a compelling case for terraforming, with its physical similarity to Earth, its proximity, and its potential to support human life. While the challenges are significant, they are not insurmountable, and the rewards could be immense. Transforming Venus into a habitable world could provide a new home for humanity, advance our scientific and technological capabilities, and offer strategic benefits for the future of space exploration. At the same time, it would require us to grapple with the profound ethical questions about our role in the universe and our responsibility to future generations. Terraforming Venus is an extraordinary endeavor that presents numerous challenges, many of which are significantly more daunting than those associated with other potential terraforming projects, such as Mars. These challenges stem from Venus's extreme environmental conditions, complex atmospheric chemistry, and the need for advanced technological solutions. Overcoming these obstacles requires a deep understanding of planetary science, innovative engineering, and a long-term commitment to gradually transforming the planet into a habitable environment. One of the most significant challenges of terraforming Venus is its extreme surface temperature. Venus is the hottest planet in the solar system, with surface temperatures averaging around 467 degrees Celsius, 872 Fahrenheit. This intense heat is the result of a runaway greenhouse effect, where the planet's thick atmosphere, composed mostly of carbon dioxide, traps heat from the sun. The heat is so intense it can melt lead and is far beyond the tolerance levels of any known life forms or human-made materials designed for long-term habitation. Reducing the surface temperature of Venus to levels that are compatible with human life would be a monumental task. Several strategies have been proposed, each with its own set of challenges. One approach involves deploying giant solar shades or reflectors in space to block or reflect some of the sunlight reaching Venus, thereby cooling the planet. These structures would need to be enormous, possibly spanning thousands of kilometers, and would require advanced materials and engineering to construct and maintain. The logistical and economic challenges of building and positioning these shades, combined with the need for constant adjustments to ensure they remain effective, make this a highly ambitious solution. Another potential method is to alter the composition of Venus's atmosphere to reduce its greenhouse effect. This could involve removing large amounts of CO2 or introducing compounds that can reflect sunlight or absorb heat in a way that reduces surface temperature. However, the sheer volume of CO2 in Venus's atmosphere, about 90 times the mass of Earth's atmosphere, makes this a Herculean task. Additionally, the chemical reactions needed to sequester or transform CO2 on such a massive scale are not yet fully understood or developed. Some proposals suggest using controlled volcanic eruptions or other geological processes to release aerosols into the atmosphere, which could reflect sunlight and cool the planet. While this is theoretically possible, it would require precise control over Venus's geological activity, something that is currently beyond our capabilities. Moreover, the environmental consequences of such interventions are difficult to predict and could lead to unintended side effects. In addition to its extreme temperatures, Venus has an atmospheric pressure at the surface about 92 times that of Earth. This pressure is equivalent to the conditions found nearly a kilometer underwater on Earth, making it lethal to humans and highly challenging to any form of surface infrastructure or habitat. The crushing pressures would not only make human habitation impossible without significant protective measures, but would also pose serious challenges to machinery, electronics, and construction material. Reducing this atmospheric pressure to levels similar to Earth would require the removal or transformation of a significant portion of Venus's atmosphere. One method could involve using large-scale technology to strip away portions of Venus's atmosphere into space, reducing its density and pressure. However, this process would be extraordinarily complex and energy-intensive, requiring technology that is far beyond our current capabilities. Another approach is to chemically convert the dense CO2 atmosphere into solid or liquid forms, such as carbonates, which could then be sequestered or stored. This would involve widespread deployment of chemical processing facilities across the planet, capable of handling vast quantities of CO2. The energy and resources required for such an operation would be immense, and the long-term environmental impacts would need to be carefully considered. Some researchers have proposed using climate engineering techniques to induce a controlled version of climate change on Venus, gradually cooling the planet and reducing atmospheric pressure over time. This could involve introducing specific chemicals or particles into the atmosphere to catalyze reactions that reduce pressure. However, this would be a slow and uncertain process, with many unknown variables and potential risks. Venus's atmosphere is not only dense and hot, but also toxic, composed primarily of CO2 with clouds of sulfuric acid and traces of other corrosive substances. These conditions make the planet's atmosphere highly corrosive and uninhabitable, posing severe risks to any life forms or technological systems exposed to it. The sulfuric acid clouds, in particular, would need to be neutralized or removed to create a breathable atmosphere and protect human infrastructure. Several strategies have been proposed to address the toxic atmosphere. One approach involves introducing chemical agents that can neutralize the sulfuric acid in the atmosphere, breaking it down into harmless compounds such as water and sulfur dioxide. However, the scale of this operation would be enormous, requiring the deployment of vast quantities of neutralizing agents across the entire planet. Additionally, the process of neutralizing the acid could have unpredicted effects in the atmosphere and climate. Another potential method is atmospheric scrubbing, where large-scale machines or automated systems filter and clean the atmosphere, removing toxic elements and reducing acidity. This would involve the development of advanced technological capability of operating under Venus's extreme conditions, as well as a significant investment in energy and resources. Some researchers have proposed using genetically engineered microbes or other biological systems to metabolize toxic compounds in Venus's atmosphere, converting them into harmless substances. This approach would require extensive research into synthetic biology and planetary ecosystems, as well as careful management to prevent unintended consequences or ecological imbalances. Water is essential for life, and currently Venus has little to no liquid water on its surface. The planet's extreme heat causes any water that might exist to evaporate, leaving the surface arid and inhospitable. Terraforming Venus would require the introduction of vast amounts of water to create oceans, rivers, and lakes, necessary for a stable, life-sustaining environment. Here are some possible methods for introducing water to Venus. One of the most straightforward, though challenging approaches, would be to import water from other celestial bodies, such as comets, icy moons, and asteroids. This would involve capturing or redirecting these objects to impact Venus, releasing their water upon collision. While technically feasible, this method would require advanced space engineering and a deep understanding of orbital dynamics. The environmental impact of such collisions would also need to be carefully considered, as they could potentially trigger volcanic activity and other geological disturbances. Another approach is to produce water directly on Venus by chemically combining hydrogen with oxygen. This could involve extracting hydrogen from the planet's atmosphere or importing it from space and then reacting it with oxygen, which could be produced by breaking down CO2. This method would require significant amounts of energy and advanced chemical processing technology, but could be a more controlled and sustainable way of introducing water to the planet. Some researchers have suggested that as the atmosphere is gradually transformed and the planet cools, water vapor currently trapped in the atmosphere could condense in the liquid form, creating clouds and eventually rain. This natural process of water formation would take a lot of time and would need to be carefully managed to ensure that it leads to the formation of stable bodies of water. Venus has an extremely slow rotation, taking about 243 Earth days to complete one rotation on its axis. Increasingly, its day is longer than its year, as it takes about 225 Earth days to orbit the Sun. This slow rotation results in prolonged periods of daylight and darkness, with each lasting for several Earth months. Such long days and nights would create extreme temperature fluctuations, making it difficult to establish a stable Earth-like environment. Addressing Venus's slow rotation would be a significant challenge. One approach could involve creating artificial day-night cycles using orbital mirrors or shades to simulate shorter periods of daylight and darkness. These structures could reflect sunlight into the dark side of the planet or block it from the day side, helping to moderate temperatures. However, this would require precise control and coordination, as well as significant engineering and resources. Some researchers have speculated that it might be possible to speed up Venus's rotation by using large-scale interventions, such as redirecting asteroids or comets to impart angular momentum to the planet. It would also provide water. While theoretically possible, this would be an incredibly complex and risky endeavor, with many unknowns and potential side effects. Alternatively, human habitats on Venus could be designed to cope with the long days and nights, using advanced climate control and energy storage systems to maintain stable living conditions regardless of external temperature fluctuations. This approach would require sophisticated technology and energy management, but could offer a more practical solution in the short term. The process of terraforming Venus would require technological advancements far beyond what we currently possess. These include the development of large-scale atmospheric processing systems, advanced materials capable of withstanding Venus's harsh conditions, and energy sources that can power the massive infrastructure needed for such a project. Additionally, the logistical challenges of transporting resources, equipment, and personnel to Venus, as well as maintaining and repairing infrastructure in such a hostile environment, would be enormous. Terraforming Venus would require vast amounts of energy for both atmospheric modification and for supporting human habitats and infrastructure. Developing efficient and reliable energy production and storage systems that can operate in Venus's extreme environment is a critical challenge. Solar power, which is abundant on Venus, could be a key energy source, but it would need to be harnessed and stored effectively to be used during the long nights. Other potential energy sources include nuclear power or advanced fusion reactors, though they would require significant advancements in technology. The materials used in constructing habitats, vehicles, and infrastructure on Venus would need to withstand extreme temperatures, pressures, and chemical corrosion. Developing such materials would require advances in material sciences and engineering, potentially including the use of novel composites, ceramics, and other high-performance materials. These materials would also need to be durable and repairable, as the harsh environment would take a toll on any exposed surfaces over time. Given the hostile conditions on Venus, much of the initial terraforming work would likely need to be carried out by automated systems and robots. These machines would need to be highly resilient, capable of operating autonomously for extended periods, and able to perform a wide range of tasks, from atmospheric processing to construction and maintenance. Advances in artificial intelligence, robotics, and autonomous systems would be essential to the success of such a project. The logistical challenges of terraforming Venus include transporting equipment, materials, and personnel to the planet, as well as establishing and maintaining supply lines. Developing reliable and cost-effective space transportation systems, as well as efficient methods for landing and deploying large-scale infrastructure on Venus, would be critical. This could involve new rocket designs, space elevators, or other innovative transportation technologies. Terraforming Venus would be an incredibly time-consuming and costly endeavor, likely taking centuries or even millennia to complete. The sheer scale of the project, combined with the need for ongoing maintenance and adjustments, would require a long-term commitment from multiple generations and possibly international cooperation. The cost of such a project would be astronomical, far exceeding any current space exploration budgets. Financing and sustaining such a project over the long term would require innovative funding mechanisms, international partnerships, and perhaps the development of new economic models. The potential economic benefits for a terraformed Venus, such as access to new resources and the expansion of human civilization, would need to be weighed against the immense initial investment. Finally, the ethical and environmental implications of terraforming Venus must be carefully considered. Transforming an entire planet would have irreversible consequences, potentially destroying any existing ecosystems or geological features of scientific value. The ethical debate over whether humanity has the right to alter other planets for its own benefit is complex and multifaceted. Moreover, the environmental risks associated with such a project are significant. Any mistakes or unforeseen consequences could lead to catastrophic outcomes, not only for Venus, but potentially for the broader solar system if, for example, changes to Venus's atmosphere affected its interactions with other celestial bodies. While the challenges of terraforming Venus are immense, they are not insurmountable. With the right technological advancements, careful planning, and a commitment to ethical and sustainable practices, it may one day be possible to transform Venus into a habitable world. However, the risks and complexities involved require a cautious and considered approach, with a clear understanding of the long-term implications for such an ambitious project. Terraforming Venus into a habitable world is an undertaking of unprecedented scale and complexity. The roadmap for terraforming Venus must be approached as a phased, long-term project that will span centuries, if not millennia. Let's explore the various stages that might constitute a viable roadmap, including initial preparation, early terraforming efforts, immediate phases, and the final transformation. Each stage would require significant technological advancements, international cooperation, and careful planning to ensure the project's success and sustainability. Before any physical efforts can begin, the first phase of the roadmap involves extensive preliminary research and exploration. This stage would involve sending a series of robotic probes or manned missions to Venus to gather detailed data on the planet's atmosphere, geology, and potential resources. Understanding the full scope of Venus's environmental challenges is critical for developing effective terraforming strategies. The initial phase would involve sending sophisticated robotic missions to map Venus's surface in high detail, analyze the composition of the atmosphere, and study the planet's geological history. These missions would also search for signs of subsurface water, analyze the sulfuric acid clouds, and investigate the possibility of dormant or active volcanic activity. The data collected from these missions would inform the design of future terraforming technologies and help identify potential hazards. Following robotic exploration, the roadmap would call for manned missions to Venus's upper atmosphere, where conditions are less extreme. These missions would likely involve the establishment of cloud cities or orbital stations to serve as the basis for further research and testing of terraforming technologies. Manned missions would allow for more detailed scientific investigations and provide invaluable experience in operating under Venus's challenging conditions. Simultaneously, significant resources would be dedicated to the development and testing of the technologies required for terraforming Venus. This would include advancements in atmospheric processing, climate engineering, robotics, and materials science. Testing could be conducted on Earth, in space, or on other planetary bodies with similar conditions, such as Venus-like environments in laboratory settings. Once preliminary research is complete, the next phase involves initial efforts to modify Venus's atmosphere. The primary goals of this phase are to begin reducing surface temperatures and atmospheric pressures to create a more hospitable environment for future stages of terraforming. This phase is likely to be the longest and most complex, requiring large-scale interventions and careful monitoring. A key strategy in this phase could involve the deployment of solar shades or mirrors in space to reflect sunlight away from Venus, reducing the planet's surface temperature. These shades would need to be positioned at the L1 Lagrange point, where they could remain stable between Venus and the Sun. The cooling effect of these shades would gradually lower surface temperatures, potentially allowing for the condensation of atmospheric gases and a reduction in the greenhouse effect. The construction and deployment of solar shades would be an immense engineering challenge, requiring advanced materials that are lightweight, durable, and capable of withstanding space conditions. The shades would also need to be adjustable to maintain optimal positioning and reflectivity over time. Concurrently, efforts would need to be made to begin removing or chemically transforming the vast amounts of CO2 in Venus's atmosphere. One approach could involve deploying atmospheric processing plants that capture CO2 and convert it into solid carbonates or less harmful compounds. This could be achieved through chemical reactions that bind CO2 with other elements, potentially producing useful byproducts such as oxygen or water. This phase might also involve the introduction of engineered microbes and nanotechnology designed to catalyze the conversion of atmospheric CO2 into less volatile forms. These biological or chemical agents would need to be carefully controlled to avoid unintended environmental consequences. The production of water is a crucial step in this phase, as water is essential for both life and the further modification of Venus's climate. Water could be produced by introducing hydrogen, imported from space or extracted from the atmosphere, and reacting it with oxygen, produced by the breakdown of CO2. Alternatively, water-rich comets or asteroids could be redirected to impact Venus, releasing their water content into the atmosphere and maybe increasing the angular momentum of the planet. The introduction of water would help to cool the planet, contribute to the formation of clouds, and begin the process of creating bodies of water on the surface. However, careful management would be required to ensure that the water does not immediately evaporate or become trapped in the atmosphere. As the initial atmospheric modifications take effect, the roadmap would transition into intermediate phases aimed at further stabilizing the environment and preparing Venus for more extensive human habitation. These phases would focus on the gradual transformation of the planet's surface and the development of sustainable ecosystems. Cloud cities would serve as early human habitats during the terraforming process, providing a safe environment for scientists, engineers, and other personnel to live and work. These cities would float in the upper atmosphere, where temperatures and pressures are more manageable, and could serve as bases for ongoing terraforming operations. The construction of cloud cities would require advances in material science, energy production, and life support systems. These habitats would need to be self-sufficient, capable of producing their own food, water, and energy, and would likely rely on advanced recycling technologies to minimize waste. During the intermediate phases, efforts would be made to manage Venus's geological and volcanic activity, which could play a significant role in the planet's long-term stability. This might involve controlled releases of volcanic gases to help cool the atmosphere, or the introduction of artificial geothermal systems to regulate surface temperatures. Geological activity could also be harnessed to aid in the terraforming process, such as by using volcanic eruptions to release aerosols that reflect sunlight, or by trapping geothermal energy for power generation. However, the risks associated with manipulating a planet's geology would need to be carefully considered and mitigated. The process of transforming Venus's atmosphere would continue throughout the intermediate phases, with ongoing efforts to reduce CO2 levels, increase oxygen content, and manage atmospheric pressure. As surface temperatures drop and pressures decrease, it might become possible to begin introducing more advanced forms of life, such as plants and microorganisms, to help stabilize the environment and produce oxygen through photosynthesis. This phase would also involve the gradual creation of more Earth-like weather patterns, including the formation of clouds, rain, and wind systems. The development of these natural processes would be essential for establishing a stable climate and preparing the planet for eventual introduction to more complex life forms. With the atmosphere increasingly stabilized, the roadmap would move to the large-scale surface transformation phase. The focus here is on creating habitable land, water bodies, and ecosystems that can support human life and sustainable agriculture. This phase would likely involve the most visible and dramatic changes to Venus's surface. One of the key goals of this phase would be the creation of oceans, rivers, and lakes. As temperatures continue to drop, any existing water vapor in the atmosphere would condense, potentially leading to rainfall and the formation of bodies of water. Additional water could be introduced through methods discussed earlier, such as importing it from space or producing it chemically. The distribution of water across Venus's surface would need to be carefully managed to ensure the creation of stable, life-sustaining environments. This might involve the construction of artificial dams, canals, and reservoirs to control water flow and prevent flooding or droughts. To support terrestrial life, Venus's surface would need to be transformed into arable land. This would involve the creation of soil, either through natural processes or artificial means, such as the introduction of organic material and minerals. Once the soil is established, the planting of hardy, genetically engineered plant species could begin. These plants could help to stabilize the soil, produce oxygen, and lay the foundation for more complex ecosystems. The introduction of plant life would need to be carefully planned to ensure that the species selected are capable of surviving Venus's still harsh conditions and that they contribute positively to the planet's evolving environment. As the surface becomes more hospitable, the construction of permanent human habitats and infrastructure would begin. This would include building cities, transportation networks, and energy production facilities. These structures would need to be designed to withstand any remaining environmental challenges, such as temperature fluctuations, windstorms, or residual atmospheric pressure. The development of infrastructure would also involve establishing systems for food production, waste management, and resource extraction, all of which would need to be sustainable and scalable as population grows. The final phase of the roadmap involves the stabilization of Venus's environment to create a fully habitable planet capable of supporting a thriving human civilization. This phase would focus on fine-tuning the climate, composing the introduction of diverse ecosystems, and ensuring that the planet's resources are managed sustainably. Even after extensive terraforming, Venus's climate would require ongoing management to ensure stability. This might involve the use of advanced climate control technologies, such as orbital mirrors or atmospheric processors, to maintain ideal temperatures and control precipitation to prevent extreme weather events. Weather control systems could also be used to prevent destructive storms, regulate rainfall, and ensure that temperature and pressure remain within safe limits for human habitation. These systems would need to be robust, reliable, and capable of operating autonomously to minimize the need for human intervention. With the planet's climate stabilized, the final step in the environmental transformation would be the introduction of complex ecosystems, including animals, insects, and diverse plant species. These ecosystems would need to be carefully balanced to ensure that they are sustainable and that they do not disrupt the planet's overall stability. The introduction of life to Venus would be a gradual process, starting with simple organisms and gradually building up to more complex forms of life. The goal would be to create self-sustaining ecosystems that mimic those found on Earth, with the potential to evolve and adapt to Venus's unique conditions over time. As Venus becomes fully habitable, the focus would shift to ensuring that the planet's resources are managed sustainably to support a growing population. This would involve the development of closed-loop systems for energy, water, and food production, as well as the responsible extraction and use of natural resources. The establishment of government structures and economic systems that prioritize sustainability and cooperation would be essential to prevent overexploitation and ensure the long-term viability of human civilization on Venus. The roadmap for terraforming Venus is an ambitious, multi-phase plan that requires a deep understanding of planetary science, advanced technology, and a long-term commitment. Each phase of the roadmap presents its own set of challenges, but with careful planning and international cooperation, it may one day be possible to transform Venus into a new home for humanity. The journey to a habitable Venus would be long and complex, but the potential rewards, the new world for human civilization, make it a vision worth pursuing. This video is just the beginning of an in-depth exploration of terraforming Venus. In this series, we'll take a detailed, step-by-step approach to this grand endeavor. We'll delve into the specific technologies and scientific principles that would be required to transform Venus into a new Earth. Each subsequent video will build on the concepts introduced here, covering topics such as cooling the planet, the conversion of the atmosphere, the construction of habitats, and the introduction of life. We'll also explore the ethical, social, and political implications of terraforming Venus. This includes considering who would have the right to live on the newly terraformed planet, how resources would be managed, and what kind of society might emerge. By the end of this series, you'll have a comprehensive understanding of what it would take to make Venus a new home for humanity. This first video serves as the gateway to the entire series, setting the stage for the detailed exploration that follows. This introduction provides an overview of the topics to be covered, emphasizing the importance of terraforming Venus as a potential solution to long-term survival of humanity. Each subsequent video will focus on a specific aspect of terraforming Venus, delving deep into the technical, scientific, and ethical challenges involved. This series will be organized into about 17 episodes, each approximately an hour-ish long. about the same length this ends up being, to ensure that every topic is covered in sufficient detail. The structure allows for a gradual buildup of knowledge, with each episode building on the concepts introduced in previous ones. We'll explore the concept of terraforming itself, defining what it means and why it's significant. The discussion will include historical context, tracing the origins of the idea in science fiction and its evolution into a serious scientific proposition. We'll address the ethical implications of altering an entire planet and the potential benefits and risks associated with such a monumental task. You'll gain an understanding for the fundamental goals of terraforming and how it fits into the broader context of space exploration and human survival. The next episode will focus on why Venus, rather than other planets like Mars, is considered a viable candidate for terraforming. The discussion will cover Venus's similarities to Earth, such as its size and gravity, and the potential advantages it offers for human colonization. We'll also address the challenges posed by Venus's extreme environment and how these might be overcome. Then we'll take a closer look at the specific challenges involved in terraforming Venus. The harsh conditions of the planet, its thick atmosphere, extreme temperatures, and corrosive clouds pose significant hurdles to any terraforming efforts. We'll explore the scientific and engineering challenges in detail, discussing current theories and potential solutions. The goal is to provide a realistic assessment of the difficulties ahead, emphasizing the need for advanced technologies and innovative approaches. We'll outline the potential roadmap for terraforming Venus, breaking down the process into manageable phases. You'll learn about the initial research and exploration required, followed by early atmospheric modifications, intermediate stages on surface transformation, and the final steps to create a habitable environment. We'll also discuss the timeline and resources needed for each phase, giving you a sense of the long-term commitment required for such an ambitious project. Terraforming Venus will require an enormous amount of energy and technological innovation. We'll explore the various energy sources that could be harnessed, from solar power to nuclear and fusion energy. The discussion will also cover the technological advancements needed to develop and deploy these energy systems on Venus. We'll emphasize the role of innovation in overcoming the practical challenges of terraforming, highlighting how current research could pave the way for future breakthroughs. We'll delve into the science of atmospheric engineering, focusing on the methods and technologies that could be used to modify Venus's atmosphere. The discussion will include the potential for solar shades to reduce temperatures, chemical processes to convert CO2 into oxygen, and other strategies to make the atmosphere more Earth-like. We'll also explore the challenges of maintaining atmospheric stability over the long term, considering the delicate balance required to sustain life. Water is essential for life, and we'll explore the various methods of producing or managing water on Venus. You'll learn about the potential sources of water, such as comets or chemical reactions, and the technologies needed to create and distribute water across the planet. We'll also focus on the challenges of water management in the newly terraformed environment, including the risks of flooding, drought, and contamination. Once Venus's environment is more hospitable, the next challenge will be developing habitats and infrastructure for human settlers. We'll explore the design and construction of cloud cities, surface habitats, and transportation networks. The discussion will cover the materials and technologies needed to build durable, sustainable structures that can withstand Venus's harsh conditions. We'll also address the logistics of supporting a growing population, including food production, waste management, and energy supply. Maintaining a stable climate on Venus will be an ongoing challenge, even after the initial terraforming phases are complete. This episode will explore the technologies and strategies for long-term climate control, including the use of orbital mirrors, weather control systems, and artificial ecosystems. The discussion will also cover the risks of climate instability and the need for continuous monitoring and adjustment to prevent catastrophic failures. Transforming Venus into a living planet requires the creation of new ecosystems. We'll delve into the science of ecological engineering, focusing on the introduction of plants, animals, and microorganisms to Venus. The discussion will cover the selection of species, the creation of soil and habitats, and the challenges of establishing a self-sustaining ecosystem. We'll also address the ethical considerations of introducing life to a new world, including the potential impact on any existing life forms or geological features. We'll provide a detailed exploration of the energy sources that could power a terraformed Venus. This discussion will include solar power, nuclear reactors, and the potential for fusion energy, as well as innovative energy storage and distribution systems. We'll explore the challenges of generating and managing energy on a planetary scale, including the need for redundancy and backup systems to ensure a stable power supply. Technological innovation is critical to the success of terraforming Venus. We'll explore the specific advancements needed in areas such as materials science, robotics, automation, and AI. The discussion will cover the role of these technologies in overcoming the challenges of Venus's environment and enabling the large-scale engineering required for terraforming. We'll also highlight the current research and potential future breakthroughs that could accelerate the process. The environmental and ethical implications of terraforming Venus are complex and far-reaching. We'll explore the potential risks of altering Venus's environment, including the impact on any existing ecosystems and the broader solar system. The discussion will also cover the ethical debate over humanity's right to terraform other planets, weighing the potential benefits against the irreversible consequences. You'll be encouraged to consider the moral responsibilities associated with such a transformative project. The governance and economic models needed to support a terraforming project of this scale are unprecedented. This episode will explore the potential for new forms of cooperative governance, moving beyond traditional notions of nationality and capitalism. The discussion will cover the challenges of managing resources, coordinating international efforts, and ensuring equitable access to the benefits of terraforming. We'll also explore the innovative funding mechanisms, such as public-private partnerships, international collaborations, and potentially new economic models that prioritize sustainability and cooperation. Terraforming Venus would have profound socio-political implications, both on Earth and on Venus. We'll explore how this project could reshape human society, including the potential for new social structures, cultural developments, and political systems. The discussion will cover the impact of terraforming on global power dynamics, the potential for new forms of identity and citizenship, and the role of technology in shaping the future of human civilization. Humanity has a long history of large-scale engineering projects, from the construction of cities to the exploration of space. We'll draw lessons from these past endeavors, exploring what they can teach us about the challenges and opportunities of terraforming Venus. The discussion will include case studies of successful and unsuccessful projects, highlighting the importance of planning, innovation, and adaptability. You'll gain insights into how past experiences can inform the terraforming roadmap and help mitigate risks. We'll wrap up with a look to the future, exploring the potential impact of terraforming Venus on human civilization. The discussion will cover the long-term benefits of expanding humanity's presence in the solar system, including the potential for new scientific discoveries, economic opportunities, and cultural developments. We'll also address the broader philosophical implications of terraforming, including what it means for humanity's place in the universe and the future of our species. The series will conclude by reflecting on the journey from the initial concept of terraforming to the detailed exploration of its many facets. You'll be left with a comprehensive understanding of what it would take to terraform Venus, as well as the potential rewards and risks of such an endeavor. The series will emphasize the importance of continued exploration and innovation, inspiring viewers to think critically about the future of humanity and our place in the cosmos. As we journey through this series, keep in mind that while the challenges are immense, so too are the possibilities. Terraforming Venus is not about creating a new planet. It's about pushing the boundaries of what humanity can achieve, rethinking our role in the universe, and imagining a future where we can live among the stars. This is the grandest of human endeavors, one that could define the next era of our existence. As we wrap up this first episode in our series on terraforming Venus, we've laid the groundwork for what will be an extensive and thought-provoking journey into one of humanity's most ambitious and daring endeavors. We've explored the concept of terraforming, tracing its origins from the imaginative worlds of science fiction to its current status as a serious scientific proposal. We've delved into the significance of terraforming, not just as a technical challenge, but a potential solution to some of the most pressing issues facing our species today. We've examined why terraforming is more than just a theoretical exercise. It represents a profound shift in our relationship with the universe, where humanity is no longer confined to Earth, but is instead poised to become an interplanetary species. The potential to create a new Earth-like environment on Venus offers not only a backup plan for humanity's survival, but also an opportunity to expand our civilization in ways that were once unimaginable. The significance of terraforming goes beyond the technical feats it requires. It's about envisioning a future where humanity has the capability to shape entire worlds, where we can create new habitats that offer fresh starts and new possibilities. This vision is not about survival. It's about thriving in a universe full of potential. However, as we've discussed, the path to terraforming Venus is fraught with challenges. The planet's hostile environment presents significant obstacles that will require innovative solutions and unprecedented levels of international cooperation. The technical, ethical, and environmental challenges we've touched on in this episode will be explored in greater detail as we move forward in the series. These challenges, while daunting, are not insurmountable. History has shown us that humanity is capable of achieving the extraordinary when we combine imagination with determination. The concept of terraforming Venus challenges us to think beyond our current limitations and to push the boundaries of what is possible. This first episode has set the stage for the detailed exploration that lies ahead. In the coming episodes, we'll dive deep into the specifics of how terraforming Venus might be accomplished, from the initial steps of atmospheric modification to the complex task of establishing sustainable ecosystems. We'll explore the energy requirements, the technological innovations, and the socio-political implications of such a monumental project. As we continue this journey, each episode will build on the concepts introduced here, gradually expanding our understanding of the many facets of terraforming. By the end of this series, you'll have a comprehensive understanding of what it would take to transform Venus into a new home for humanity. The possibility of terraforming Venus invites us to reimagine the future of our species. It challenges us to think beyond the confines of Earth and to consider what kind of civilization we want to build in the cosmos. The pursuit of terraforming is not just about creating a new world. It's about defining the next chapter of human history. As we close this episode, consider the profound implications of what we've discussed. Terraforming Venus is a concept that stretches our imagination and challenges our sense of responsibility. It's an idea that asks us to dream big while remaining grounded in the realities of science and ethics. As we close this episode, consider the profound implications of what we've discussed. Terraforming Venus is a concept that stretches our imagination and challenges our sense of responsibility. It's an idea that asks us to dream big while remaining grounded in the realities of science and ethics. Thanks for tuning in. I hope you found this video informative and thought-provoking. This is the point where others tell you, if you enjoyed it, give it a thumbs up and consider subscribing for more content just like this. But we know that kind of thing is for losers. Don't be a loser. And as always, I welcome your feedback and ideas for future videos in the comments section below. Until next time, keep exploring, keep learning, and keep embracing your inner nude, dude.